CE 497, Introduction to Human-Robot Interaction. I'm Dr. Carlotta A. Berry, your professor. Today we will have Lecture 5 on Human-Robot Interfaces. Recall that my PhD work is actually on human-robot interaction, in particular human-robot interfaces, where I designed a sensory egosphere to enhance a human-robot interface by adding sensor data from the perspective of the robot's ego, which was a geodesic dome, where sonar data, IR data, camera data, and more was displayed with respect to the robot to see if that would help the user to understand how to remotely control a robot by increasing the situational awareness and reducing mental workload. So today we're going to learn more about human-robot interfaces and how they can be used to increase or improve human-robot interaction. The objectives for today's lecture are to provide an overview of human-robot interfaces, describe 5 types of human-robot awareness, compare and contrast map-centric and video-centric interfaces, list interface design guidelines to improve human-robot interaction, and list several interface lessons for fully and semi-autonomous mobile robots. Although these interfaces are discussed in the context of mobile robots, students should also be thinking about, in terms of a social robot, what type of interface or screen could you design to afford or to help a user to interact with your social robot in order to increase things like understanding, communication, situational awareness, improve their ability to accomplish a task, etc. The goal of human-robot interfaces is to afford or to help with human-robot interaction, such as aiding the human's knowledge of the robot's surroundings, location, activities, and status as gathered from the interface, and also to help with the human's comprehension of the robot's state in terms of situational awareness. This video is an example of a rescue robot GUI while the robot is mapping in a rough terrain. So what you see here is the robot is moving through the cluttered environment, and on the left you can see it is building the world model or the map that looks like a PackBot. And as it's driving through the space, it's also improving on the map when it encounters obstacles and clutter. So the question would become, since this is a human-robot interface, can you tell when the robot is making forward movement? Can you tell if the robot is getting stuck? How accurate is that map with respect to the interface and the environment? And if the robot was on a mission to identify, let's say, the human baby or the baby doll, was it able to see that and capture or pick it up? I don't think it did. It passed it on by. But this would be an example of a human-robot interface where the human is using this screen as well as other screens in order to determine something about the environment. So as we've talked about before, situational awareness can be improved with the addition of a human-robot interface, where you're looking at situational awareness with respect to human with the context of the robot, human to human, robot to human, robot to robot, or even overall mission awareness based upon perception, comprehension, and prediction. And lasso is a way of defining, in terms of these 5 types of human-robot awareness, composed of location, activity, surroundings, status, and overall awareness. Thinking about the human-robot interface we just saw. Where was the robot in the world? What activity was it currently performing? Was it picking up the baby doll? Was it moving over an obstacle? Where were in the surroundings, as I said previously, anything of importance, such as that baby doll? What's the robot's status? Is it actively moving? Overall mission awareness. If the mission was to rescue that doll, how did it do? So here are some examples of remote robot interfaces from the context of the map or versus the camera. And there are obviously debates about which one would be better for mental workload, situational awareness, mental fatigue in trying to process all the information from a camera feed versus having a map that shows the robot on it with some kind of IR or sonar data. Which one would be better for remote control? And maybe it's dependent upon the mission or the task. So here, for the map-centric approach on the left, may be most effective in providing good location and status awareness, but video-centric, which is on the right, may be more effective in providing good surroundings and activities awareness. And you may find that neither interface has an advantage for overall mission awareness, which may be the case that you want to have both available so that the user or operator can then switch back and forth based upon their needs. So here's a paper by Keys that looks at interface evolution and how things change based upon what the interface looks like. Version 1 on the top left has a main video screen as well as a rear view camera, map mode, and status panels. And then on the bottom left, they moved the video panel to the center of the screen because they found that more people are relying on that camera video view, and it's placed in the perspective view below the video screen and may turn gray to yellow to red as objects get closer to the robot, which is helpful so that the robot does not hit obstacles from the front or back. It also rotates in response to the panning of the camera. In version 3, they replaced the distance panel with a zoom mode inspired by that panel. And instead of colored boxes and lines drawn around a scale model of the robot, it is based upon actual sensor data. And this version could also be controlled with a keyboard or a joystick. And then finally, the bottom right is version 4, where you still keep the visual presentation in the middle while replacing the input method with multi-touch gesture activation versus the joystick. And the robot now has braking control and the visual feedback. So the visual feedback is maintained because you find that people are most comfortable with visual or camera feedback, maybe because they know that the most from television or cell phone images, etc. So when you're designing interfaces, things to think about is important information should be presented close to the video screen because most users are most reliant on that video screen. So if it's something you really want them to know, keep it close to that space. A good thing to do for a mobile robot is to have a second camera that faces the rear because most obstacles will be hit from the rear. And also the robot should have an automatic direction reversal mode for when they're driving the robot backwards. And you may want to use that camera which is rear facing to help with that. And it would also be helpful if there are some basic behaviors or autonomous modes for the robot. Those are quickly available somewhere close, so that if you want to quickly switch into wall following or object retrieval, etc., the user does not have to expend mental workload to achieve that. So here's another example of map-based interfaces on a handheld device, which may be more practical for instructing a robot in a limited space, where you may have a typical synchronous and co-located human-robot interaction in the home environment, where the human is given an instruction and the robot provides feedback, or the bottom, where you have two instruction modes, where you have the three-dimensional image and the two-dimensional map based upon the needs of the user and which one may be the most helpful. Here we look at interface lessons for mobile robots, but remember, even in the context of your static social robot, you can be thinking about interfaces that would be most appropriate to engage a user to want to interact with your robot. Beyond just seeing the robot and wanting to interact, what kind of interfaces could you have on a computer screen? So things to consider are safety, remote awareness, control. How do you control the robot command inputs? How do you give command inputs? We've talked about gesture recognition, facial recognition, joysticks, verbally speaking, etc. What is the current status of the robot? How do you recover the robot? And how do you design the interface in order to make it the most effective for the robot and for the human? So safety lessons for interface and design including how do you make a robot that fails in a safe state? Most importantly, when you have a robot that is driving in the wild, you want to make sure that if it's about to fail, it doesn't fail in a place that either endangers people or maybe even destroys the robot. Make sure you have an emergency stop on the robot and at the operator location. You may want to also have a software shutdown in addition to a physical hard stop. And you may want to have veto power as the operator when you have direct line of sight to the robot, even if the robot is fully autonomous and there's something or some perception that the operator can provide that the robot may not recognize, so that you can shut it down when you see it's about to be in one of those hazardous or dangerous situations. So remote awareness lessons help the user understand the remote environment. The video and map view should be available. Provide multiple channels of data at the same time. Fuse sensor data on the display is maybe helpful, such as maybe having camera, IR, laser, and sonar to give distance information. Have a high degree of accuracy and world model. Have a dashboard layout that is easy to follow and understand. And make sure interfaces units match control units. So let's take a look at this graphical user interface for single human, multiple robot system. We won't show this whole thing, but notice you're going to have a lot more going on if one human has to control multiple robots. So what you see in the upper left is the camera view for each of the robots. And then on the right, as the robots are driving through the world, and you can see on the screen one robot through the other robot's camera. And you can see there is a radar of data for the sonar and LiDAR as the robot's moving around to see how it encounters obstacles. And then if you look at the map view on the bottom left, you can also see the current location for all three of the robots and where they are with respect to each other. So this is a user interface that may be overwhelming based upon the amount of information, or just right, depending upon the mission or task that the human must direct the multiple robots to achieve. So control lessons for interface design. You want to allow multiple levels of control, sliding or scalable autonomy based upon things that the robot can do without human intervention, or if there's going to be a neglect time versus when the human should be able to use shared autonomy or mixed initiative to step in and take over, be able to rapidly identify the robot's level of autonomy, and have an agreement between the operator, mental models, and the robot behavior, so that the operator is actually commanding the robot to do things that are within the robot's scope, and that the robot recognizes the intentions of the human and when the human can take over. So looking at input lessons for interface design, control should support input from alternative views and also alternative methods like we talked about: facial recognition, gesture recognition, speaking, natural language processing, etc. And there should be some macro actions for semi-autonomous systems. Macro actions are some things that can be done completely autonomous, where the operator does not have to use mental workload in order to direct the robot. If there's some things the robot can just do automatically, for example, wall following, obstacle avoidance, etc. So status lessons for interface design. Operators should be able to rapidly identify the robot's health and motion characteristics and provide values like direct speed, tilt, pitch, roll, and health alarms. So recovery lessons for interface design. What if the robot fails? Once we've already said we want it to fail in a state that is usually safe and recoverable, and be able to permit still rapid situational awareness and overrides, even though the robot has failed, to provide integration of information or color coding for confidence and alarms. How confident is the robot that it has failed and that the user needs to now intervene in order to rescue the robot. And with that, we conclude this week's lecture on human-robot interfaces. Make sure you review this as well as the weekly readings, take the quizzes, and thanks for coming to listen and learn.